Hi guys, this video is on sets of numbers and their representation on the number line. So the first concept is that any line is made up of an infinite number of points. Between any 2 points on this line, there's an infinite number of more points. Each individual point on the line has no width. That's why you can always can squeeze in more and more and more points. So every single point on this line represents a unique number. As you go to the right, the numbers are greater. As you move to the left, the numbers are less. So you should always set up your number lines so that more or greater is to the right. This is true even if you're dealing with entirely negative numbers. For example, if you had negative 10, over here might be negative 12. Negative 10 is greater than negative 12, so it's going to be to the right. It's also important to note that numbers that are equivalent, in other words 5 over 1, 10 over 2, which simplifies to these, 500%, they are all the same identity and they will share one unique point on the line. The number line is super useful because it allows you a visual representation of what's happening in terms of different sets of numbers. For example, if you have to give the odd numbers, you would be circling 3, 5, 7, and so on. With an arrow, you can show that the trend continues. Notably, things you're not doing are the numbers, all the numbers that are in between. You're talking about specifically just 3, 5, 7, and so on. If it switched to even numbers, obviously we'd be talking about 2, 4, 6. We would also be talking about 0 and negative 2. Again, you can draw arrows to show that the trend continues. Go ahead right now, pause the video, and see if you can quickly sketch all the negative numbers on the number line. Make sure you write it in your quad book so I can see it. Okay, so hopefully when you did negative numbers, you had to say there's a border here somewhere, starting at 0. And down here is negative 1, negative 2, negative 4, so forth and so on. But it's not just negative 2 that's negative, but it's everything to the left of 0 that's negative. By shading in all these dots, you've shaded in all the infinite number of points that are negative. Next, please pause the video and see if you can sketch in specifically all the non-positive numbers. Okay, so with any luck, hopefully you realize non-positive was very similar to the negative numbers. However, there's one other number that is non-positive, and to include it, you would want to darken 0, because that is neither positive nor negative, and then you would show everything over here. Essentially, this answer has only one more solution than the graph of all negative numbers. Sometimes when we're working with numbers, it's important in algebra to limit the number of possible numbers you can use. Some numbers aren't really useful. One of the first sets of numbers you deal with are the set of whole numbers. These numbers begin at 0 and they go 1, 2, 3. This is how this might be written if you're doing set notation. Go ahead and see if you can give a quick number line sketch of the whole numbers. Pause the video now. Okay, so when you went to sketch the whole numbers do not include any fractions. The first one is 0. You would want a dot on 0. You want a dot on 1. You want a dot on 2. You would then draw an arrow indicating that all the numbers greater following in this exact same pattern. The integers are the whole numbers and their opposites. Integers are whole numbers and their opposites. So integers would look very similar to 1, 0, but it would also have negative 1, negative 2, negative 3. Integers are commonly used when you have counts of things, like elevation or how many dogs in a park. Whole numbers actually would be better for dogs in a park. Integers are good for things that go above and below 0. But in general, both of these are numbers that are used in counting. Two very large sets of numbers are the rational numbers. Think of ratio, something that can be written like a fraction. And irrational numbers, numbers which cannot be written like a fraction. 1/3 is rational. 3 is rational. It's the same as 3 over 1. Repeaters, 0.3 repeated, is rational because it can be converted into a fraction. Irrational numbers are numbers, say for example, if you had a square with an area of 10, the side of that square is the square root of 10, which is a number that doesn't end and doesn't repeat. If it repeated, we could turn it into a fraction and it would be rational. Another famous irrational number is pi. It doesn't end and it doesn't repeat as far as we can tell. Okay, for a couple quick homework problems. First question is, can you please draw your own number line with equal spacing so you have a uniform scale. So if this distance here is 1, all other gaps between intervals must be 1. If this is 10, same thing for all other gaps. Graph 6, 1, 0, -1, and -5, and they're opposites on a single number line. You might want to draw some connecting lines so you can see a number and its opposite. Similarly, draw another line. Graph 6, 1, 0, -1, -5, and the reciprocal of these numbers. All that should be on a separate number line. Lastly, a little extra credit. Are there more irrational numbers on the number line, or are there more rational numbers on the number line? Might have to think about that one. Okay, please show all your notes on your work and be ready to have your quad book open when you come to class so I can check out your notes and check out your solutions to these two problems. Thank you.